With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello everyone, so today we are going to discuss one question of mean value theorem. Here in this question we are given two statements. This is the statement 1 and this is the statement 2. And now after reading these two statements, we need to choose one among these four options. And these four options are regarding these two statements. So let us first focus on the statement 1. Here in this statement we are given that there is no such value of k which exists. No such value of k exists for the equation x cube minus 3x plus k is equals to 0. So that this equation has two distinct roots in between the range 0 to 1. Now let us consider this expression as f of x. So we get f of x is equals to x cube minus thrice of x plus k. Now let us assume that f of x is equals to 0 has two distinct real roots in the range 0 to 1. So if this is true, then f dash x is equals to 0 should have at least one root in the range 0 to 1. F dash x is equals to 0 must have at least one root in the range 0 to 1. So let us compute f dash x is equals to 0. So if we compute this, we get 3x square minus 3 is equals to 0. And from this we get two values of x, that is x is equals to plus minus 1. So now from this discussion it is crystal clear that f dash x is equals to 0 does not have any root in the range 0 to 1. So now whatever we have assumed in the beginning must be false. That is, we have assumed that fx is equal to 0 has two real roots in the range 0 to 1. But now this is not true. So this assumption is not true because this is contradicting now. And hence we can say that the statement 1, from the statement 1, this f of x, this expression is equal to 0 has no distinct roots. For any real value of k, this has no distinct roots between 0 and 1, and hence the statement 1 is true. Now let us focus on the statement 2. In the statement 2 they have given that x is greater than sin x for all values of x greater than 0. So let us assume a function g of x. Let us assume g of x is equals to x minus sin x for all values of x greater than 0. We have kept this restriction. Now if we apply Lagrange's mean value theorem on this g of x function, then we apply this Lagrange's mean value theorem on the interval 0 to x. So by applying Lagrange's mean value theorem on the interval 0 to x, we get g dash c is equals to g of x minus g of 0 whole divided by x minus 0. And on further solving we get g dash c as it is. And g of x. So g of x is x minus sin x. So we get x minus sin x minus g of 0, which is 0, whole divided by x minus 0, that is x. So g dash c is x minus sin x by x. And here from the Lagrange's mean value theorem, this c always belongs to the interval 0 to x. Now we compute g dash c. So g dash x is basically From this we get the value of g dash x, which is 1 minus cos x. And from this, if we substitute x is equals to c here, then we get g dash c as 1 minus cos c. So instead of g dash c in this result, we write 1 minus cos c. So here we write 1 minus cosine of c is equals to x minus sine x whole divided by x. Now since we know that cos c will always be less than 1, less than equals to 1, so this term will be always greater than 0. So since this term is also equals to this, so we can say that this right hand side would also be greater than 0. So we just remove this equality and place this term as greater than 0. So we conclude that x minus sine x whole divided by x will be greater than 0. And from here we get the value of x minus sine x greater than 0. That is x is greater than sine x. So we have concluded this. Now let us move on to the statement 2. So in statement 2 it is given that x is always greater than sine x for all values of x greater than 0. And here we have proved that also. That is for all values of x which is greater than 0, we have proved that x is greater than sine x. Now this statement 2 is also correct. So we can conclude that the statement 1 is correct, the statement 2 is also correct, but the statement 2 is not the correct explanation of statement 1. So both the statements are correct, but statement 2 is not the correct explanation of statement 1, and hence option 2 is the correct answer. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.